CoQ10. So as we age over the age of 25, it becomes more important to supplement or take CoQ10 supplements, especially if you're on a statin medication, because that drastically reduces the body's ability to use CoQ10. Heart essentially runs off of CoQ10. One of the studies said deficiency will weaken the heart and may cause congestive heart failure. So that's a concern with these medications. Interesting studies have been done. So a couple studies looked at, can these statins lower cholesterol? And almost every study shows statins will lower cholesterol every single time. Reduces your LDL cholesterol by huge amounts. But the interesting thing is in the studies, they don't show that they reduce the risk of death at all. So even though higher cholesterol may be associated with heart disease, when you artificially lower the cholesterol, the chance of death doesn't go down. It stays the same, even though the cholesterol goes down. So an example of this might be if we looked at a bunch of people who had heart disease and we looked at the color of their hair, we might find that the color of their hair was gray. Now if I artificially change the color of their hair to blue or blonde or brown, it doesn't mean that it's going to change their heart disease, it just means that they have a different hair color, even though the person is still associated with having heart disease.
I'm assuming they're taking these thinking just the opposite.
Exactly, yep, because it definitely shows that if the cholesterol goes up, that you have a higher chance of having heart disease. And we would think that if you lower your cholesterol, you would have lower chance for heart disease. But
is this because of the coenzyme Q10 and other
that's
things
one
like
of the
that?
factors that's there. But there's something else that is a much higher telling factor of whether or not you're going to have heart disease. Even though cholesterol is a problem, it's not the major problem. It's actually much less significant than what people like to believe. Artificially lowering it doesn't change your chance for death. It actually stays the same. In some cases, in some studies, it shows that the rate of death actually goes up. So when they looked at women over the age of 65 that were on cholesterol-lowering medications, they found that even though their cholesterol is lower, their odds of death actually increased. So it's very interesting. Multiple studies show that statins reduce the cholesterol, but saves no lives compared to patients on a placebo. May increase your chances of cancer up to 50%. This was an interesting study. 50% of the people on statins showed some type of side effect, whether it was muscle weakness, joint pain, damage to the joints. That's actually the primary one that causes people to go off of the statins, because all the damage is happening to the muscles and the joints. Patients over 70, higher cholesterol actually meant lower chance of death, lower Alzheimer's, and lower chance of cancer. It basically comes back to this slide right here. Cholesterol is required by our body in order to function. So if our brain needs cholesterol and we're artificially lowering the cholesterol, our body's going to be forced to take cholesterol out of something. It's going to lower it. Drugs are very good at lowering the cholesterol, so it's going to pull it out of the brain or out of the joints or out of the nerves. We're not going to have that vital cholesterol there that's going to be necessary to run and to function. So we definitely need cholesterol. Now, because cholesterol is part of vitamin D, and vitamin D is very strong at helping the body not to have cancer, we can't make enough vitamin D because we don't have enough cholesterol, then cancer rates will start to go up. The major problem, though, is the reason why our cholesterol is going up stays the same, even though we're taking medication to lower the cholesterol. So let's say we're eating food that's causing our cholesterol to go up. We take something to lower the cholesterol, but we keep eating the same thing. It's not changing the reason why the cholesterol is going up. Cholesterol goes up in response to something. Unless we change that, it doesn't matter by artificially lowering it. It's like if in your car, the engine is malfunctioning, and the check engine soon light comes on, we put a piece of black tape over that check engine soon light, or pull out the little fuse to turn off the check engine soon light. Even though the check engine soon light isn't on anymore, doesn't mean that we fixed the problem with the engine. That's what we need to look at. Interesting new studies. Even though we just learned that cholesterol is important for the brain, now we're saying that some of the new studies are saying that we might start giving them to children as young as 8 because we're starting to see signs of heart disease in kids as young as 8 years old, and we've been led to believe that cholesterol is a problem. So if we can give kids cholesterol medications, we can reduce the cholesterol younger, but it's not fixing the reason why there's the problem. So not the answer. Why would we think this? There's a lot of money to be made in giving cholesterol medications to kids at a younger and younger age. When you look at compliance, the people that are the most compliant with taking medications are actually kids, because the parent tells them take this, the doctor tells them take this, and kids listen. Adults, sometimes we don't listen as well. We go off medications without asking, without following directions. So the compliance isn't as high in adults as it is in kids. So that's lots of money to be made there. So understanding the good versus the bad, both these terms I would say are misleading. Both LDL and HDL do certain things. HDL, which is what we call the good cholesterol, carries fat material, including cholesterol, between the cell to the liver. HDL has actually been shown to be a better predictor of heart disease than LDL. Most of the medications are for lowering the LDLs. A lot of times when we look at a blood test, we're looking at total cholesterol, which is HDL plus LDL. So we want a higher HDL, but lower total cholesterol. It doesn't really make sense when we add those up, because we want this one to be nice and high, so we can carry that fat back to the liver to get it metabolized. LDLs carry fat from the liver out to the cells in order to make cholesterol, to make different hormones and make things that our body needs. And so this is a better predictor of a healthy heart, is how the HDL is doing. But we want that to be higher, so obviously we can't just go based on total cholesterol. We need to look at the numbers there. We like LDL to be lower. It's going to tell us there's less fat being transported from our liver out to the other cells. But we need some of that. So why do we get high blood pressure and high cholesterol in the first place? You should have this diagram in your little packet. It might be the second page. And this diagram is kind of the neurology behind how stress works in the body. So when we look at stress, it's the category on the right-hand side. It doesn't matter whether it's a mental stress, physical stress, or chemical stress. So whether it's stress at work or school from a family member, chemical stress, like something we're eating, something that's bad in our environment, chemical stress on our body, or physical stress like subluxation or whatever, we're going to cause stress on our body. Now when we put stress on our body, it's interpreted by our brain and our nervous system, and we form a stress response. So the best example of this I can give you is, let's say we're walking down the road, it's on a nice leisurely walk, and a dog jumps out at us, kind of a pit bull or some ferocious dog. We kind of get into that, hold on, wait a second here, I either need to A, fight for my life, fight this dog off, or B, turn tail and run and get out of here. And so our body prepares us to do that. That's called a fight or flight response. And so when this happens, our blood pressure goes up because we want to pump more blood into the arms and the legs and allow us to either A, fight, or B, run. If our blood pressure stays the same, we'll burn through the blood that's currently in our arms and our legs very rapidly, and we'll fatigue fast, and we either won't be able to run very far or won't be able to fight for very long. So our blood pressure needs to go up to pump more blood out there. Cholesterol goes up naturally because we're burning through hormones very rapidly in order to get our body ready to fight or run. And so as our hormones are being reduced, our body releases more cholesterol to go out to the cells to make more hormones so we can replace the stuff that's being burned through. Cortisol will go up, and what cortisol does is it causes us to crave sugar, burn sugar, and store fat. So as our stress levels go up, we store fat for later when we can rest and recover and burn fat, and our sugar goes up because we want sugar in the bloodstream. Blood clotting goes up because in case an animal would now attack us, we would want to be able to survive and clot our blood, and insulin resistance goes up. Normally insulin would pull blood sugar levels down, we want our blood sugar levels to stay high so we have lots of energy to run away from this animal. So we can see short term